Hi everyone, welcome to lesson 3, linear relationships, stage 5.1. Today's learning intention is here. I want you to be able to find the distance of an interval. So to do this, we need to revise Pythagoras' theorem. And remember, when we do questions, we do it in our workbook. So these questions in your workbook. So Pythagoras' theorem is up here. C squared equals a squared plus b squared. Or you can use this one over here. So it's just taking the positive square root. So for question 18, find C, so the hypotenuse, when a equals 4 and b equals 3. So remember Pythagoras' theorem, the hypotenuse, C, is opposite the right angle. A and b are the other two values. So a equals 4, so this must be a, because there's 4 units. And this must be b, because there are 3. So using this version, we get the square root of 4 squared plus 3 squared equals 5. If you do the other version, you'll get exactly the same answer. So find C when a equals 5 and b equals 2. Same thing. Square root of 5 squared plus 2 squared, which is 5.39 to 2 decimal places. And then for question 20, find C. We've got decimals this time, but it's the same process. 7.2 squared plus 3.6 squared. So we get 8.05 to 2 decimal places. Next ones. Okay, so when we do the revision questions, you should pause the video and do the questions yourself and then listen to the answers. It's the best way to do it. This time when you find A, that's the shorter side of the triangle, so we have a little bit different process. So c squared equals a squared plus b squared is Pythagoras' theorem. What we need to do is rearrange it so that we can find one of the shorter sides. So effectively what happens is this b squared gets taken away from c squared to give us a squared. So a squared equals c squared minus b squared. So we go hypotenuse, the big side, 13 squared minus 5 squared, which is 12. So for this one, find b. So b is also a shorter side, not a hypotenuse. So it's 10 squared minus 5 squared. And we take the square root to go from b squared to b. So we get 8.66, 2 decimal places. For our notes, we're going to use Pythagoras' theorem. So if you don't get Pythagoras' theorem, we need to go through that. These are the examples for your notes book. Remember, when you're making notes, you should be writing in your annotations. So the things that will help you remember. Example 4, find the distance AB. So as soon as we think distance, we think Pythagoras' theorem. So AB squared, I'm just using capitals here, AC squared plus BC squared. So when we have the capitals here, that's why I'm using capitals. AB is the distance between A and B. If we're using lowercase, C is opposite C, A is opposite A, and B is opposite B. So we normally have it with lowercase, like in the revision questions, but we can use capitals as well. So AB squared equals 3 squared plus 4 squared. And then when that square root disappears, it goes over this side. We have this positive value. And on that, we do that part on our calculator and we get 5. So it's just like Pythagoras' theorem, but we're using the Cartesian plane as well. So the distance between 2, 1. So you plot that point across 2, up 1, 5, 5. So we go across 5, up 5, and that's our point B. So just extending Pythagoras' theorem to the Cartesian plane. You can set it out like this, which if you're happy, I'd prefer you to use this way. It's very similar to this, so if you do it this way, it's not a problem. Questions for your workbook? So try these before you listen to me do it. So pause the video, do it, and then see if you are correct. Find the length of the line. So we can draw in a right angle triangle. So you can kind of think about rise over run, except for now it's going to be rise squared plus run squared, because it's actually Pythagoras' theorem. So this side is 3, this side is 3. So Pythagoras' theorem, it's not gradient. A squared plus B squared, 3 squared plus 3 squared, which is 4.24 to 2 decimal places. Question 24, have a go, pause the video. First step, draw in the right angle triangle. Measure the sides, so 2. So we're going from 2 to 4. You should always check the scale. 1, 2, 3, 4, 5. So it goes from 7 down to 2, or up from 2 to 7. So the difference between these two is 5. Count 1, 2, 3, 4, 5. And then we use Pythagoras' theorem. So again, this bit, 2 squared plus 5 squared, 5.39 to 2 decimal places. Question 25. So the harder problems will just start with the 2 points. So we can graph it. We can draw the graph. So draw in the line here. 3, 1, remember we go across 3, up 1. 5, 2, we go across from 0, up there. So make this right angle triangle. Straight lines would be better. 1 here, 2 here. So 1 squared plus 2 squared. And find the square root of that is 2.24 to 2 decimal places. As always, you should reflect on your learning. So add comments that help your learning. In your words is always better. And you need to convince a friend that you can describe how the distance between 2 points can be calculated using Pythagoras' theorem. Okay, good luck. Let me know if